Okay, so I'll spend a few minutes discussing our project on enabling personalized videos and recommendations, and would like to acknowledge my co-PIs, Trong Nguyen and Nuno Vasconcelos. Okay, so we are looking at two major trends here for video. One is personalized videos. Well, I shouldn't have said for videos. One is personalized videos, and the other is personalized recommendations. And many of you are already recipient of personalized recommendations in various forms. And in terms of the content, Netflix or other kinds of content, advertisements, social professional networking, video caching, and so on are the applications. And our overall, the way we envision this is that if we can get to know what the preference of users are, then maybe we can do personal advertisement, personal recommendations, personal content for them. So, so we came up with this concept that that people will have different preferences, and that concept, that hypothetical concept, came from a lot of internet studies which showed that internet usage, that is, which websites each person is going to, that is definitely depending upon the individual user. So each user had preferences on what website they went to. But we wanted to, we wanted to bring that concept to video and assume that each of us will have different choices of video or different preferences for video. And we wanted to confirm that and wanted to ask the question that what kind of videos do people watch? Now, we found that there are various studies nationally done, not only in US, various parts of the world, which shows what videos people are watching. And so if you look at on the right-hand side, this shows essentially one such distribution. And most of these studies showed that the popularity distributions of videos, that is, which videos are popular on a given day, over a month, over a year, and so on, typically follows this kind of exponential curves. And people have tried to model it using ZipF and various distributions. But essentially, some videos are very popular, and then there is a long tail. Okay? Now, this is for all users combined together, and we wanted to ask the question, what about individual users? And we couldn't find that data. So eventually, somewhat reluctantly, I'll come to that, but we wanted to ask these questions: what videos do individual users watch? And are these viewing patterns different from the aggregate viewing patterns? And do individual users have certain preference for certain categories? And these preference patterns for categories of videos, are they different for different individual users? And lastly, how do we define video categories? Do we just go by what YouTube defines or ESPN defines, or is there a different way of defining these video categories? So we wanted to do some user studies. And as I said, that this is the one that I mentioned the word reluctantly because it involves various things, and we don't do these user studies that frequently. But we started conducting a user study, collecting videos that people are watching. And this is completely anonymous, and the privacy is completely protected. And I would also, because we have started doing this process, and I'll show you some results of this, I would also request you and encourage you to go to this website, and you can do this study in 10 minutes. Okay. So what did we learn from the data that we have collected so far? Now, here we are using categories identified by YouTube. And what I'm going to show here are some users. We have done this for, obviously, many, many users, and for some users. Now, if you look at this particular user, user 8, anonymous, so this user likes to see a lot of music videos and likes to see what is categorized by YouTube as entertainment videos. Comedy videos comes the third, and so on. So you see a pattern here with preference for certain category of videos, and then a second degree preference, third degree preference, and so on. We call this the user preference profile of this particular user. Now, obviously, this user preference profile will keep changing. If you had kept monitoring this user's the videos that he or she watches for more and more time. Now, if you look at the second user that we are putting up here, user 3, then we see that his or her preference is very different from the preference exhibited by the first user. So this person likes to watch a lot of sports videos, and then these are some other categories. So overwhelmingly sports, but there are other categories there. And then if you look at the third user, which is this, has again different kind of categories. Not a huge preference for one, but still significant preference for comedy, and then so on, the orange bars, and the corresponding dial. I'm just going to show 5 users here. The point here we are trying to make is that each user seems to have preference for certain categories, and their preferences seem to be different from each other. Now, so one of the questions I'd asked is, do individual users have preference for certain categories of videos? Obviously, the answer is yes, from what we have seen up to now. And are they different? Are the preferences different from each other? And it seems they're different. So when we do a pairwise correlation between their preferences, it's a mean of 0.63 and a standard deviation of 0.24. So yes, there are some similarities, but then there are also significant differences. And then we answer the question, how do these preferences look like? How do these preferences for categories look like? And interestingly, they seem to follow a similar kind of curve that for the aggregate video popularity that I had shown before. And so if you look at, what we have plotted here are for each user, how their interests look like, how their preferences look like. And if you see for the green user, this is the top category, this is the second top category, and so on. And on the left-hand side is the fractional interest for each of the category. So while they're different, but if you look at the aggregate here, it follows an exponential curve. So the point is that there is an existence of strong preferences for the users, for each individual user, for their own set of categories. And this definitely then can be used to personalize content, personalize recommendation, if we can identify what those strong preferences are, right? So what this empirical study is showing, that each of us have some strong preferences for different categories of videos, and if we can identify those strong preferences, then maybe we can serve content or other recommendations in a more personalized way. Now, we had introduced, last time we had given a presentation, a framework in which if we know the set of categories and if we can gather enough training data, then we can come up with contextual models. Now, this training data is gathered from a lot of metadata that is available from online video sites. For each online video, there is a lot of metadata. And so gathering that metadata, and we can come up with a training set, and using that training data and the category names and so on, we can come up with a contextual model. And then online, when you are watching video, for every person watching video, we can try to categorize for each video that you are watching, what is the category of video, okay, using this contextual model. And then if we keep track of this for some time, then we can figure out what your preferences are. So that's what we had proposed last time, and coming up with algorithms with different kinds of accuracies and so on. Now, over the last few months, we asked the question that, well, for a fixed set of categories, like giving YouTube gives or some other online provider gives, this is all doable. But do these set of categories, are these the right set of categories for different applications? So if you look at some different applications, for instance, if you want to use these preferences for categories for serving the right kind of movies, but for movies, you need different kinds of categories like action, horror, comedy. Do you like action movies? Do you like horror movies, and so on? And those kind of categories are different from the online categories. Similarly, if let's say a personalized application, say Sears wants to do personalized advertisement for you, but Sears would like to know which kind of department you might like, and in each department, what kind of product you may like. So these are different kind of categories than what these online video categories are. Similarly, if, say, Sports Chalet wants to do personalized advertisement for you, their categories would be different. Similarly, there is a separate work that we are doing where we are using user preferences, what user likes or not likes, to understand how we cache videos in a cell site. So essentially, the idea is that as people go into a cell site and come out, we are keeping track of people and what their preferences are, and accordingly cache videos. Again, for this application, we need really different kind of categorization. So we wanted to answer the, obviously, different applications need different kinds of categories, and thereby the methodology that I showed last time would not work because that methodology is for generic set of categories. And here, for different applications, if you need different kind of categories, you need to come up with different training data set. So what we did was we came up with a platform, a framework or methodology where given any set of categories, however fine those categories are, we can come up with a good set of training data so that we can come up with those contextual models so that then we can use those contextual models online to determine what categories of videos you are looking at and thereby what preferences you might have. So the methodology is simple. For each category in this new set of categories, we find keywords from various sources like Wikipedia, and there are various ways you can get keywords for them. For each keyword, we evaluate whether it's a good keyword or not. And this is what I'll be talking about briefly, what we mean by good keywords. So, and then once we determine a good set of keywords for this category, we go to YouTube, we go to other online video sites and get training data. That is, videos, we look up by the keyword and get the videos, and that constitutes the training data set for that category. And thereby we come up with the entire training data. Now, so what we did was we answered the question, what are good properties for these training data? For example, sometimes when we gather this training data, these training videos for each keyword, sometimes wrongly labeled videos come in. So obviously, natural property would be to have a low fraction of wrongly labeled videos. Similarly, we also found out that a low fraction of videos that do not belong to any of these categories is a desirable property. A property that is very desirable is that videos which give high coverage of diversity within each category. So you can come up with a set of training data which is good for a part of the video category but might not be good for all the category. For instance, if the video category is action film, then you may come up with a lot of training data, training videos for martial art movies, but you might miss out on other kinds of action films. So this is what you want to also avoid. Now, what we also did, we also looked at keywords and identified what are good properties for keywords. So for instance, one good property for keyword is that if I'm looking for keyword for a certain category, that keyword should not be something that it correlates to all the different categories that I'm looking at. Because otherwise what will happen is that the videos that you get as trading videos, they'll also belong to all these different categories. So essentially, low relatedness to other categories in the set of categories that you are looking at. Similarly, a high relatedness to the category of concern. And another property we found useful is low similarity with category name or other already chosen keywords. Now, I know that I'm going through this very fast, and but the general impression that I want to leave you with is that it's possible to identify good properties for keywords, and it's possible to identify good properties for training data and then correlate them. So for instance, certain properties of keywords correlate well with certain training data properties and so on. And then we can potentially come up with techniques, and we have just started coming up with techniques. We can potentially come up with techniques where as we are given a set of categories, then we identify keywords for each category and then evaluate those keywords for those properties, for the good properties of keywords. And if they fit those good properties, then we know that this keyword is good, and then we use the keyword to get training data. So for instance, one such technique where we query with not only the keyword, but also with all the categories that we are given. And let's say the RVK is the retrieve videos for using category keyword K, and RVCI is the retrieve videos for each of the categories using the category name. And then what we can do is we can collect all the videos by looking up, form a bag of words representation, and then what we do is we find correlation between these bag of words representations. Essentially, we are trying to find out the similarity between the keywords, the videos obtained by keyword K and the videos obtained by category name CI. And then we can apply, once we have this relatedness, we can apply to see whether this keyword fits in with these three properties that I just mentioned. And if it fits in, then it's a good keyword. So this is one of the techniques we are trying to come up with other techniques. And what I'm showing here is some preliminary results where if we just use, let's say the set of categories is this: action film, horror film, comedy film, romantic film. And if we use just the category name, then we get a 51% accuracy in terms of determining whether which category you are looking at, how accurately we are determining that. So again, I may not have stated that right. So by using the category name, we are getting a set of training data. By getting that set of training data and doing the modeling, and then using that model during online video categorization, we are getting 51% accuracy, saying that what you have watched, what category of video you have watched. We can increase that categorization to about 56% using just the technique that I just mentioned. Not a huge jump, but some improvement. Similarly, we have tried out on various different categories, and we get some improvement. So clearly, we are getting some improvement, but we have a long way to go in finding out better ways of finding training data. I want to spend about a few 2-3 minutes on another part of our research, and that is developing interactive video. Now, what we are doing is we are developing the enabling technologies to develop personalized or interactive video in the following way. So imagine we have a video, and we want to composite in it, put in it some other objects. Now, last time what I presented was our research where we extract depth maps for objects, and because depth maps are important, the depth information gives you the geometrical and structural information of the object, and once we have good depth map, then we can put the object into some other video. So imagine an augmented reality kind of application. Now, what we are doing here is that to be able to do this in 3D scenes, imagine a 3D scene where I want to put an image of someone into it, a live image of someone into it, as opposed to an avatar, for instance. Then we have to extract 3D model for this image or for this object. So this is exactly what we are doing here, and I'll show you some visually. So for instance, if this is the 3D object, then our method, what it does is it scans the 3D object 360 degrees and gets the color data as well as depth data. The depth data we get using the Kinetic from Microsoft, and we use that together with our enhancement techniques that we presented last time, and to create models, 3D models of it. Now, once we create the 3D model, then we can essentially render any kind of image on the fly into that 3D scene. And this shows the improvement over Connect, because Connect also has Connect Fusion, which can do the same thing. But if you look at, so the top row is what Connect does, and the bottom row is what we do. And so if you look at the top row and the bottom row, you see remarkable difference in the quality of the reconstruction. So this is, again, a step. What I presented to you are two things. One is, how do we understand user preferences given any set of categories, so that we know how to personalize recommendations or personalized video for you. And the second is, second part of the research is looking at the enabling technologies which will let you personalize some of the video. And in this case, by personalization, what we really mean is creating interactive videos, creating videos where you can put in other scenes or other objects into the video, according to your choices. Okay, that ends my talk. Thank you. Yes. Right, so these volunteers we just chose arbitrarily from the set of volunteers that took our study. We were not looking at any social aspect or demographics aspect when I showed you this. Maybe what we used is, to highlight the differences in user preferences. But in our study, I see your question. In our study, we are trying to look at different demographics. Because if you just look at if most people participating in our study are, let's say, in their 20s, then maybe the data will be biased. We are trying, but see, getting volunteers is not the easiest thing, as you can imagine. So I would say that we have got volunteers in different age groups, but I would like it to be, this is the start of the study, and I'd like it to be much more broad-based. I don't think it's as broad-based. It's mostly university-based at this time. And it's not as broad-based as to, for instance, I would not be ready to publish these results yet. I would not have that confidence because I think it has to be much more broad-based. Yes.
When you categorize the video, you mainly use the metadata, you don't get into the content itself?
Right, good question. So there are techniques. Actually, one of my colleagues, Nuno, he gets into the content. It gets into the video and gets into the actions that the videos have. And actually, last time I did present some of his work also. So much can be learned by getting into the video and understanding for attributes. It has definitely its advantages. It works for, it does not work for online videos. It works for maybe portal videos, sort of prepared content, right? Movies and other kinds of content. This other piece of work that I just presented does use the metadata because it's very fast. Processing is very fast. As soon as you try to get into the video itself, the processing becomes slow. So this effort is really looking at the metadata. We are looking at including some things like audio, which can be much faster processed. But at this time, it's looking at metadata and understanding categorization. Thank you.